Hi, okay, this is part 2 of our parts review for the Sias EDM. Today we cover Small Hole EDM. Last episode was Die Sinker. The Small Hole EDM here is thin walled stainless steel tubing with I believe a 1.6mm rod. Went through at an angle. This was actually part of one of my demo videos. And there is another one. Let's see where the other hole is. Here's another hole. It works pretty well. Okay, so that was stainless steel, high tensile steel, like this high tensile steel bolt. This is a 1mm rod. The nice part about this is it does not leave any burrs, so you can use the nut and it doesn't get stuck at all. No deburring necessary, and because you run on this one, we ran through electrode flushing, cools the electrode, cools the workpiece, no unnecessary heat stress. If you spark at high current for a really long time, yes, you'll get a little bit of heat stress around the periphery and definitely heat stress in your recast, but that is a topic for a whole different day. And you also have harder material. This is high-speed steel, 8% cobalt. Also went through there. High-speed steel and the high tensile steel ran about 1mm a minute. Next, it's called Small Hole for a reason. Here's a little hardened stainless steel. I'm not sure how hardened it is. Ruler, I think it's 0.7mm thick. There you have your 1.5mm hole. Got a 1mm hole, 0.75, 0.5, 0.3. So try and see if we can see that 0.3 with this little magnifying glass. It's 0.5, 0.1, 0.75. Should be able to see it there somewhere. Okay, but you can see it, otherwise I'll zoom in like crazy on that thing. Okay, and you can also do small holes in very small parts. There's a little needle, hypodermic needle. Well, it's not that little needle, I think it's an 18 gauge, but still it's a little, I think this is a 0.5mm hole through the tip of the needle. And then the big advantage of Small Hole EDM, it's a non-contact process, so it doesn't really care how long the workpiece is. This is EN19B steel. That is the other name for it is SAE 4140. You may be more familiar with. Just over 7 inches, 180mm, 1.5mm rod. The Sias machine can do this. It did do this. Not ideal though, but it's not ideal because of the machine, it's ideal, not ideal because of the flushing. With this machine, or this cut, I ran down about 40mm. About that much at 1mm a minute, so that was fairly on par with my previous cuts, but then it just drastically tapered off because your flushing has to be intense to get all that particles out, otherwise you get a lot of recutting, wasted energy on the shaft as it comes out, and you get a lot of electrode wear. So to cut this took a ridiculously long time. I'm not even sure exactly how long, but more than an hour was definitely the case. A couple of hours actually. But like I said, the problem was with flushing. And the other downside of the flushing is because you cut so long and you didn't have a proper ejection of all the particles very rapidly away from the electrode. I got a lot of bell mouthing right at the tip of the entry hole, where you'll see on the exit hole there's barely anything, because you just ran straight through. But again, you can do it, but secret is flush, flush, flush. So that's it for part 2, all the small hole parts. I hope you'll join us for part 3, where we'll do all rotor parts, where that's where the fun really starts. Thanks, bye.